Hello everyone, I'm Lida.
This is Leslie. Hello.
And welcome back to Learning with Lily. So today we'll be talking about how to solve for the limiting reactant and the percent yield.
So first, let's learn how to solve for the limiting reactant. As you all know, a limiting reactant in a chemical reaction is the substance that is used up first, stops the reaction, or limits the amount of product that can form. We can see our first problem here. How much zinc chloride can be produced from the reaction of 2 moles of zinc and 3 moles of hydrochloric acid, which is the limiting reactant, which is the excess, and how many moles of it are left over. So the first step for solving for the limiting reactant is we have to balance the equation. But as you can see in the example, the equation is already balanced. So we can move on to computing for the limiting reactant.
Hey guys, so the right side of the screen, as you can see, will provide the problem, so you'll be guided. So first, it will be easier if we start with the given. So we got 2 moles of zinc and 3 moles of hydrochloric acid. So to determine the limiting reactant, we must first determine how much of one reactant the other reactant requires to react completely. So let's start with zinc. You can start with HCl if you want, but I'll start with zinc. So we've got, from the given, 2.0 mole of zinc, or rather 2 moles of zinc. Now, we'll multiply that with our balance equation from our reactant side, as you can see on the right side of the screen. So 2 moles of HCl and 1 mole of zinc. So from this, we can multiply. So we need to determine how much HCl do we need for the 2 moles of Zn to react completely. So if you multiply 2 times 2 and then you divide by 1, it's equals to 4. And then you can crash out mole of Zn, and what's left is mole of HCl. So this means that you need 4 moles of HCl in order to make the zinc react completely. So you do the same to the HCl. So now that we've done it to both, as you can see, we did it to HCl the same way we did to the zinc. So now we're going to compare the two. So we have 4 mole HCl and 1.5 mole of zinc. So which do you think has a smaller number? Obviously, it's the 1.5 mole of zinc. So the smaller number is the limiting reactant. So our limiting reactant is hydrochloric acid. While our excess, as you can already determine, it's the zinc. So now that we have our limiting reactant, we can use the limiting reactant to determine the maximum amount of product that can be made. So how do we do that? First, we'll solve it. So again, the problem is on the right side, so you'll be guided. So we have 3.0 moles of hydrochloric acid, which is the original given, times our balance equation, 1 mole of the zinc chloride. This is from the balance equation of the product side, over the reactant side, HCl. Mole rather. Okay, next is we multiply like normal. So we can crash out mole of HCl, mole of HCl. So it's 3 times 1 divided by 2, just like a while ago. 1.5 mole of zinc chloride. So that is our maximum amount of product. So next is we solve for the excess, or the amount left over. So do you remember our excess reactant is basically the zinc.
So we have to determine first the original amount used for zinc, subtract it to the amount that we used for the zinc, which was 1.5 mole zinc. We got that from the limiting reactant equation. So it is equals to 0.5 mole of zinc. That's the excess. So now we've solved the problem. Hope you got it.
Hello everybody, so I will be solving the percent yield. Let's try to solve the percent yield. The problem is, what is the percent yield if a student makes 5.2 grams of carbon dioxide by decomposing 9.5 of aluminum bicarbonate? So here's the given reactant. We will find the molar masses of both aluminum and carbon dioxide. The molar mass of aluminum bicarbonate is 210.035 grams per mole, and carbon dioxide, which is 44.01 grams per mole. How to find this, if you ask, is just search it in Google. So here's now the solving. Start writing the mass of the reactant using stoichiometry. So this is the mass of the first of the reactant. Here, 9.5. You write it here. We will need to use three conversion factor fractions, 1, 2, and 3. So put 1 mole in here and 1 mole in here as always. Here below, we will put the first reactant's molar mass, which is 210.035 grams aluminum bicarbonate. And in here, we will put the coefficients in this part. The 2, let's put in here, 2 mole. And this one, the carbon dioxide, 6 mole. So, in this last part, what we will put in here is the carbon dioxide's molar mass, which is the 44.01 grams CO2, like that. Since what is in here, we have to cancel it out. Cancel it out. And this one too, since they are both in here. So how to solve that one is to, like this. 9.5 divided by 210.035 times 6 divided by 2 times 44.01 is equals to, let's get that calculator. Let's try to solve. 9.5 divided by 210.035 times 6 divided by 2 times 44.01 is equals to 5.97. Answer is 5.97 grams of carbon dioxide. This carbon dioxide, because what we're looking for is the carbon dioxide. So we will round it off. That will be 6.0 grams of carbon dioxide. So we will now solve for the percent yield. So 5.2, this is the actual yield, this one, and the theoretical yield, this is the theoretical yield. So multiplied by 100%, so it will be 86.6%. I didn't make a mistake because the theoretical yield is greater than the actual yield.